Before we leave section 7.2 behind, we need to learn a little bit of an important notation. It's going to become very important for us in later statistics, and that is z with a little subscript after it. Now, we give it that a little name, alpha. It looks like a A, but it's actually a Greek letter, alpha. And that alpha has its own meaning that we'll discuss later. But suffice it to say, at this point, it's just that it's the area in the right tail. Now, that's a little strange for us because we've been seeing all along here in the decision matrix, left tail area, left comma right, left comma right. But this particular notation, because of how it is built, is always the area in the right. Alpha is this little area to the right. So I have this drawn for us here. So I have on this, you can see an area over here to the right, and I've labeled it with alpha. It looks kind of like a sideways fish, but it's alpha. And I've told us that it's 0.10. So our mission is to find and label the z-score that's shown. Well, the z-score is that vertical bar right there. That's our z-score. And I want to be able to find it. Well, let's think about this again. Finding a z-score doesn't really change the fact just because it has a subscript. So I want to find a z-score. That means that I want to, let's pull up the decision matrix. I want to find a z-score. Well, if I'm given an area, then I'm going to use inverse norm. If I'm given x values and a score, I'd use old school stuff from chapter 3. Well, I'm given an area. So they gave me an area of 0.10. So I'm going to use this part, inverse norm, left tail area, 0, 1, and so on. Okay, so I know that I'm going to use inverse norm. And now it's just a question of how. And actually, I'm going to shrink this down a little bit so we can see it. So since the area in my right tail, which is my alpha, is 0.10, that means the area in my left tail is 1 minus that, which is 0.90. So that's what I'm going to type into the calculator. So my left tail area is going to be 0.9. Right? Because remember, zeros after a decimal point don't matter. Okay, well, as long as they're extending past the numbers you've got. All right, so we're going to use, instead of 0.10, we're going to use 0.90. So inverse norm, 0.9, 0, and 1. I'm going to go to paste and press enter. And I get 1.282, right? Which makes sense. Look, it's about 1 standard deviation away, a little bit more than 1 actually. And that's where that score falls. So there we have it, right? So we know that that score is at 1.282. So I know I've kind of added a bit more in here, but you can see there's the left area right here. And there's my alpha 0.10. We didn't really have all the rest of the stuff outside, but it's fine. You don't really need it, right? And the important part is where that vertical bar is landing, which is at 1.282, which is what we just found. And the way we notate that is z with a little 0.10 after it. Or if you like, we can just say z alpha. But in this particular case, the z was the alpha was very particular. It was 0.10. So that z alpha became very special. It became z 0.10 because that's my area in my right tail. So sometimes you'll see the letter alpha there, right? If we don't know what it is, or if it's just generic. And then for our particular case, I'm going to specialize it even more and say that it was z 0.10. Right? That 0.10, when you see that number subscript, that is the area in the right tail. All right, let's see if we can understand that subscript a little bit better as we do this, because we're really going to need this in later chapters. So let's make sure we quite understand what's going on here. So I have a normal curve here, and I have a whole bunch of different z-scores marked off on the standard normal curve. And what our mission is to figure out which ones of these are which letters. All right, now the easiest one to figure is the top one. All right, so because z 0.5 means that 0.5 of your data, 50% of your data is to the right of the score. Well, that has to be letter E. It has to be, right? Because letter E is the mean. The mean has 50% to the right of it. Okay, so 50% to the right of it, that's that one. Now, number 2, z 0.003. That means I need an extremely small amount to the right of the score. Okay, so remember the whole curve makes 1, right? 100%, which is 1 in a decimal. So I need not half, not a quarter, not a tenth of a percent. I need 0.003. That's 3/1000ths. That has to be letter H. It has to be because it's the only thing that has an extremely small amount to the right of it. All right, now we're getting into some more difficult stuff. All right, so we have a z.21 and a z.345. Okay, so let's start with the basics. E in the middle is going to have 50% to the right of it, right? So anything that's less than 0.5, z.21, z.345, these two right here, it's me, 3 and 4, are both going to fall on the right-hand side of that curve. They have to, right? Because you're going to have less than half to the right of it, right? So like the H is way over to the right because it has such a small amount to the right of it. So z.21, z.345, they're both on the right. But number 3, z.21, has less on the right in the right-hand tail than number 4, z.345. 0.345 has 34.5% to the right of it, whereas 0.21 only has 21% to the right of it. And those seem like large leaps, but remember, we've seen before that these curves can sometimes be a bit misleading. So it's actually that letter G is 0.21 and letter F is 0.345. And just so you could get a sense of what this looks like, here's 0.21, and I know this seems like a lot, but that's about 21% of the graph shaded, right? There's a lot in this middle zone because it's quite tall. Whereas over here, right, at the F line, that's about 34.5% shaded to the right. And just for fun, I drew in the mean as a red line just to kind of help us visualize what's going on here. So this area to the right of this blue line is about 34.5%, which by the way means there's about, roughly 15% in between the red and the blue lines right now. I know it doesn't seem like that because it's really narrow, but it's actually really tall as well. All right, so sorry, I'm going to get that on the next page so it stops showing up. All right, now what about 0.79? All right, 0.79 means I need 79% to the left of that. Okay, well, we just said that G had 21% to the right of it, right? So over here, it looks like it has about the same amount to the left. I mean, D and G look extremely similar, yes? There we have it. All right, now number 5 and I think number 6 are actually kind of the hardest thing to look at on the page because you have to kind of get a relevance to what we've already done here. We said that G was z.21. That means that the area to the right of G is 0.21. But look at D and G. Do you see how they're equal distance from the center? That distance, which on my screen is about 2 centimeters, that distance is identical from the left to the right. That means that the area to the left of D, that blue line, is also 0.21. To the left of D is 0.21 because to the right of G is 0.21, and this graph is symmetric. Okay, well, if the area to the left of it is 0.21, then what's the area to the right of it, right? Because that's what the subscript 0.79 is. This 0.79 is the area to the, here, hold on, area to the right, right? So I want that 0.79 to be the area to the right. It has to have 79%. This has to be letter D because of symmetry, right? Because D and G are symmetrical on opposite sides of the curve, and G was 0.21. Let me write that down. There we have it. 1 minus 0.21 is 0.79. It is 0.79. So when I have the opposite of G is z.21. So z.79 it's sort of like its complement, but it's that the areas are complementary, right? So that means that it's its companion, but on the other side. So that means that this has got to be letter D, right? Now this notation here is actually going to pop up later in the course. Sometimes we'll use z.21, which is a number that's on the right side of the curve. Sometimes we'll use z.79, which is a number on the left side of the curve. But in case you missed it, those two numbers are symmetrical. So let's say, let me just pretend. Let's say G was, I don't know, 0.75, right? That was the z-score for it. Then D would be negative 0.75. If G is 1, D is negative 1, right? Matter of fact, we're going to find what it is in a second. Okay. All right, now what about negative z.21? Well, negative z means it's going to be on the left side, right, with z.21 being small amount. So this is going to start at the left side and work its way over. So negative z.21 would be equal to, you guessed it, d. It's the same number, right? Maybe it would have been better just to do number 6 first because it's the same thing, right? So the value to the left of D is 0.21 because D and G are symmetrical. So this has to be 0.21. So it has to be D. Oops, I messed that up. 1 second. There we have it. And then the last one, which is actually easier than this whole DDG business, is z.023, negative z.023. So it's going to start on the left side, and I'm going to work my way until I get 2.3%. Now you might be thinking A, but remember that H over here on the right was only 0.003, and that's with that little bit of white showing in that tail. So this A is actually more like 0.000 something, like maybe 0001 or something like that. It's got to be smaller than H. So by 0.023, I have to be bigger than H. I have to be farther over. And the answer is going to be letter B. I'm farther over with B, but I'm not too far. C is too close to 1 standard deviation away. There's no way that it's C, because C is more like, oh, I don't know, 17% of the curve shaded. I mean, if letter D is 21% is shaded to the left, then letter C is going to be something like, 15% or something like that, somewhere around there. All right, now let me prove to you the whole DGG business. Let me find, because it asks us to find a couple of them, which is pretty generic, so I'm just going to find G and D because those are so confusing. So G, by definition, means that it has to be 0.21 to the right. Let's start with G. Right? So it has to be 0.21 to the right. So that means it has to be 1 minus 0.21, which is 0.79 to the left. All right, so let me do, now remember, with your decision matrix, when you're looking for a z-score, and that's all these little z's with subscripts are, they're z-scores, you're going to use inverse norm left tail area, comma 0, comma 1, which is weird because the notation uses the right tail area. That's because we want the notation on the right tail because it'll give us positive numbers usually. It's kind of old school from back before computers. But we use left tail area because that's the way calculus works. Calculus needs the left tail area, so therefore so does the calculator, and so therefore so do you. So you need to have the left tail area. So we're going to find letter D, which is inverse norm, letter G, which is inverse norm 0.79, comma 0, comma 1. All right, let me grab the calculator. Inverse norm 0.79, 0, and 1. This should come out to the right side of 0, and it does. It's 0.806. Not quite 1 standard deviation away, which makes sense because 1 standard deviation away is over here to the right, and G is not. G is over here to the left of that, so it's not quite a full standard deviation away. So it was 0.81. There, I'll label it this way. Z.21 is about 0.806. Okay. Now another way you could label that, by the way, would actually also be Z, negative Z, here let me get this, negative Z 0.79, right? Because if you start at the left and you work your way over, the middle line would be negative z.5, right? It's positive z.5, negative z.5. And then if you go bigger than 0.50, you're going over to the other side, and 79 will get you to G, right there, right? That means that there are multiple ways, in case you missed it with this whole DD business, there are multiple ways that we can label any one of these. So we could say it's 0.21, area to the right is 0.21. We could say it's negative 0.79. Start at the left side and work your way over, right? So D is Z.21, right? Okay? Because you start on the left tail for inverse norm, because inverse norm wants left tail area, unlike your notation, which does right tail area. That's what makes these so confusing, because they go in opposites, right? So 0.21, which is going to be negative 0.086 or 0.806. If you don't believe me, let me pull up the calculator. If I do inverse norm and change this to 0.21 in here, there it is, negative 0.806. They're the same number, and that's why it had to be D and G. D and G were the only two that were the same distance from the mean. And by the way, you could also abbreviate that with negative z 0.21. So if you start at the right and work your way over, it's 79% to the right. So if you look at letter D, that line right there, right? 79% is to the right of it, 21% is to the left of it. So 79% is positive z.79, negative z.21. The negative means you start to the left. Both notations are useful, and they're both going to be used extensively in later chapters. So keep in mind, the area to the right is that little subscript, right? So that is the area to the right. If you put a negative in front of it, it flips it over and makes it go area to the left. You would always have to find these, however, with the left tail area, because the only way to find them is with inverse norm, and therefore you're going to have to use the left tail area every time. And we will do much more work with this later, but this is just setting you up a little bit, right, for how this is going to work. So remember, small areas mean you're going to be close to the tails. Big areas, right, closer to 0.5 mean you're closer to the mean. If you cross over and get bigger than 0.5, you're going to flip over to the other side. That's why z.79 is over here on the left, right? Whereas negative z.79 is over here on the right. Right? So really small amounts, like letter number 2, are you going to be in the tails. Close to 50/50 is going to be close to the middle. Past 0.5 is going to be flipping over to the other side.